problem. 1 is not enough. Okay, let's look at 38. So what I would write here, did I start it? Yes. What I will write here is this. Taking odd roots, of course, from both sides of an equation, does not require, it would be a mistake, does not require plus or minus. Be careful with that. Only when we take the square root or even index roots. So that's why I did not put plus or minus in front of 4. Okay, 38. X plus 5 again. I really didn't want x plus 5 again, but that's okay. Equals 4. So my first question is, what type of equation is it? Of course, it's not linear, quadratic, rational. It's radical. But we're going to say it's an equation with rational exponents. Okay. And we decided that we will remember to eliminate what first?
The denominator.
Excellent. How will I eliminate this denominator of 3? What should I do if it's in the denominator? What should I do to both sides? If I square, I will not eliminate the denominator. Excellent. So I have to cube it in order to eliminate the denominator. 2 over 3 times 3 over 1. Is this okay? Stop me if you have questions, please. What do we have on the left-hand side now? Excellent. Equals 4 times 4 times 4, 64. Perfect. Now, I'm asking myself, what type of equation is this? And how many solutions do I get? And the answer is, obviously, this is what type? Quadratic. And exactly which method will I use out of 4? Because it's ready for it. It's already completed. I will never use complete the square, ever. Don't force me. Oh, well, if you force me, I have no choice. But I will never, ever take complete the square. It's already factored. Sort of. What did we do here to eliminate the power 3? In the same way, we have to eliminate power 2.
So take the square.
Indeed. Yes, it's ready for that method, right? It's something with x squared equals a number. So then the left-hand side. But this time I'm applying the square root, not the cube root. So what do I have to write? X plus 5 equals? Exactly. Because I'm taking the square root. So then I move 5. X equals -5 plus or minus 8. And let's see what happens. I get 2 solutions. And on the previous example, I talk too much. That's my problem. One of the problems, I would say. I did not go back to check, right? I raised both sides to the second power, and I did not go back to check. I have to go back and check. So -1 plus 5 is 4. 4 to 3 halves. Let me show you how to, one option of 4 to 3 halves. We have to check 4 power, in parentheses, 3 divided by 2. What should the answer be if this is a solution? Indeed. Is it 8? It better be. So use the caret for the power, caret, and 3 halves. Okay, so let's go back. Now for this problem, let's finish it. There are 2 options. What are the options? X equals -5 plus 8, which is, and the other option, x equals -5 minus 8, which is -13. Of course, I have no clue whether they work or not, because in the process I raised both sides to the 3rd power. Let me give you a hint. Every time we raise both sides to an odd power, solutions will always work. So let's suppose we don't know that. So I have, I'm checking 3. 3 plus 5 to 2/3. And then I'm checking negative 13 plus 5. So this is negative 8 to 2/3. So let's go back. Go back to your graphing calculator. And I'm plugging in 8 to the power in parentheses 2/3. What should the answer be if it works? 4, very good. And then the other one in parentheses, don't forget to put parentheses around negative 8. And the power, and again to 2/3. In this particular case, although we squared, we cubed, whatever, both sides, both solutions work. I'll say yes to this, and I'll say yes to that. Yes, if we raise both sides to the 3rd, the 5th, the 7th, all solutions will work. If we raise both sides to the 2nd power, the 4th, the 6th, they may or may not. I can't tell. But if we raise both sides to cube, the 3rd, 5th, all solutions we get must work. Any questions on this? So in summary, for equations with rational exponents, I recommend eliminate the denominator first and then eliminate the numerator. And then you don't have to memorize anything. But you have to remember that. Okay? Next type is equations, quadratic. And you can say quadratic again. Well, in form. First of all, let me explain what this means before we even look at what's a problem. What is an equation quadratic in form? Is it quadratic? No. Well, so then why do I need that word in there? It only means that I can replace it if I want to by a quadratic equation using a specific substitution, an appropriate substitution. And I would write using a substitution. So first of all, why do I want to use a substitution? Because I make the equation easier to solve. Do I want to use a substitution? Most of the time, yes. Do I have to? Maybe not. But if I do, I will make my life easier. So one more time, the equation will not be quadratic. It can be replaced by a quadratic. I solve the quadratic, and then I go back and solve the original one. Okay? It sounds difficult. I hope you're not going to find it difficult. You'll see. So let's start with, let's say, 42. On the same page, 185. And that is x to the 4th minus 13x squared plus 36 equals 0. Now, you can say this is another gray area. Because this is what type of equation? If I didn't write this in here, what would you have said? Right. Degree? How many solutions? Right. So I already write on the side 4 solutions. I have to come up with 4 solutions. Okay. However, I really don't know how to factor this one. Degree 40 should have 4. Something like this, a polynomial of higher degree should have 4 terms so I can group, right? But I don't have 4 terms. So it may be a little bit more difficult to factor. But here's the alternative. So here is the alternative, the substitution that I like to talk about. Which of these two quantities is smaller? You could say, depending on x. Because if x is 0.1, is one thing. If x is 15, it's a different story, right? The one or the other will be greater. So what I should have asked is, which one has higher power? 4, right? This one. So then the smallest one, the smaller power, I'm going to say, give me a letter. Any letter you want but x. Why? We'll use B for the next one. Good. So you can say, okay, fine. So you're replacing x squared by y. Fine. Okay. But then what do you do with this? Because you can't have x and y in the same problem. So let's look at this. If x squared is y, what could this be? And I hope it is, because if it isn't, I cannot apply this method. So what do you replace this one by if this one is called y now? Indeed. So now the new equation is and this I know how to solve. And you can say, wait a minute, the original equation was in x. I'll get back to it. So let's solve for y for a minute. So how do I solve for y? Yes, you can do whatever you want. Nobody forces you to use a particular method here. You can use factoring if it's factorable. You can use quadratic formula. Will you take the square root? No, it's not ready. Will you complete the square? Please, no. It's a waste of time. It's doable, but it's still a waste of time. So then, what do I do? Excellent. So please give me the solutions for y. Remember, this is our invention. Y was not in the problem. We created y. Why? To make our life easier. So we have two options for y, which 4 and 9. Do you all agree with the options for y? But this is not the equation I need to solve. Can you please tell me what do we denote by y?
The y equals x squared.
Excellent. This is the equation I need to solve. I don't need to solve this one, but what equation I need to solve? Exactly. I have to go back to the substitution I used. Because since the problem is given in x, the answers must be in x. One more time, how many solutions we expect?
4.
Indeed. How will you solve this and what is it? Take the square root. Very good. And what type of equation is it? It's quadratic. So we applied the method of taking square roots. What do I get from here? Careful. We will not get the 4 solutions. So we got our 4 solutions as expected. That's why from the very beginning, identify from the very beginning how many solutions you expect so you don't make the error. And that was it. Okay, let's look at another. Yes, 50. Let's do 57. Let's do 58. Yes, let's do 58. On 186. And after this one, there is only one more equation till chapter 4. This is it. Let's say x squared minus 2x, everything squared, minus 11, x squared minus 2x in parentheses, and then plus 24 equals 0. Okay. So let's take a look at this. And I'm going to ask you, what type of equation is it? Correct. Awesome. What degree? When I square x squared, because I have to expand this, I get x to the 4th. So I expect how many solutions? 4 solutions. Awesome. Okay, I really don't want to expand. As long as I notice if there are 2 quantities, right, that are the same, and I could denote the one with the smallest power, which is exactly, I could denote this, and we said b, right? Was it b? Okay. However, I cannot use b and x in the same equation. I have to replace everything in terms of b. But is it possible? Because if it is not possible, this method is worthless. It doesn't apply. So what would you consider this then?
B squared.
Do you see that? Awesome. Great. Can anyone give us a new equation now? Equals 0. Excellent. Now, what type of equation is this? The one that we created in B. Why were we able to do this? Because the original equation is quadratic in form. So don't correct anything. But what if I have 3 here? Then I have b to the third minus 11b plus 24 equals 0. Is this quadratic? No, it's not quadratic. So if I replace this power by 3, I replace 2 by 3, this is no longer quadratic. So of course, now it is. Is that clear? Yes? So if the power here is not 2, then I cannot have b squared. I will have b cubed. And if I have b cubed and b and 24, this is no longer quadratic. And the original equation, it will not be quadratic in form. It will be something else that I cannot use substitution on. Good, so what do we do with this? Yes? And what is it? B? Yes, minus 3 and b minus 8. Good, so the options for b then will be? Awesome. But this is not what we're solving for, right? So the equation b equals 3 really means x squared minus 2x equals 3. Awesome. And the equation b equals 8 really means what? Now, do you understand the process that we're really making our life easier? Although it's more writing, but it reduces to quadratic equations that I can easily solve, which otherwise I would have more, it would be more cumbersome. It would be more difficult to solve. Okay, so then what type of equations are these? Right, so I have x squared minus 2x minus 3 equals 0, and the other one, x squared minus 2x minus 8 equals 0. Again, if factoring works, I will always try factoring. If it takes more than 30 seconds, don't waste your time. Use the quadratic formula. So any suggestions on how to factor? X plus 1, x minus 3, and the other one? Very good. So then we have 4 solutions. X equals, x equals, x equals, x equals. First one? Awesome. Next one? Perfect. Yes. How many did we expect from the very beginning? And we got 4. Any questions on this? As long as it works, right? As long as the method is applicable. Otherwise, should we work on another? Very good. Let's choose, let's say, 48. And 48 is x to negative 2 minus x to negative 1 minus 6 equals 0. What do we know about x to negative 1? X to negative 1 means a fraction. Which one? 1 over x. Very good. What about x to negative 2? Which is? 1 over?
1.
X. 1 over x. They cannot be the same. If this one is 1 over x, this one cannot be 1 over x. This one will be 1 over. Okay, let's talk about the formula then. So x to negative n is 1 over x to the nth power. So then, one more time, what is this?
1 over x.
And what is this?
1 over x squared.
Exactly. Very good. Awesome. So basically, this is what type of equation? At the very core. We've seen this before. It was the second equation we discussed. Rational. However, I don't want to treat it as a rational equation. Can I? Of course. Will I get the same answer? Absolutely. I don't want to treat it as a rational equation, however. Say it again. So then which of these two I will denote by whatever letter you want except x?
The 1 over x.
Indeed. Which letter you will prefer?
A.
Very good. Awesome. But if this is denoted by a, will this be what do I expected it to be? Otherwise, the method is not applicable. What do I expect this to be? Because if it isn't, I can continue with this method. Look at the previous examples, and you'll figure it out. What should it be? Of course, I hope it is. Yes, so what should x to negative 2 be if this is a? Exactly. Exactly. And it is indeed. If you square this, you get that. Just square the top, square the bottom. So of course, if this is a, this must be a squared, and it is. If you square this, you will get that. Any questions? If this is a squared. Do we understand that, or should I show again?
You showed this one.
Yes, so 1 over x squared. When we square a fraction, we square the top and we square the bottom. So if I denote this by a, this will definitely be a squared. Or you just say x to negative 1 squared, copy the base, multiply the exponents. So if you square this quantity, you will always get this quantity. Is that better? So therefore, if I denote this by a, this must be a squared. Agreed? Okay. So then, can anyone give us the new equation that we need to solve? Yes? Would you prefer to solve this, or you prefer the one with x to negative 2, x to negative 1, and negative 6? Right. Right. So this is now straightforward. It's quadratic, and of course the equation is quadratic in form because I was able to replace it by a quadratic equation. So what do we have in parentheses? A minus 3. Yes. So then we have two options for a. Very good. Negative 2 and 3. So then, of course, this is not what I'm trying to solve. Which equation am I trying to solve? Yes, 1 over x. Now it should be written as 1 over x. And then the other one will be a equals 3, which is the equation that I need to solve, which means
3 squared. I mean,
say it again. 1 over x
equals 3.
Equals 3. Very good. Good. So this is a reminder for you. I'm going to put the other side on over 1. What do I mean? What am I telling you? I'm telling you that these two are, how are they? Proportions. Proportions. Proportions indeed. So let's cross multiply. Notice that from the very beginning, I didn't say how many solutions do you think we're going to get. I can't predict. For this kind, I can't predict. Okay, so then when we multiply 1 by 1, what do we get? Good. When we multiply negative 2 by x, negative 2x. So therefore, x equals negative 1/2 for a solution. So let's cross multiply here. We get 1 equals. Very good. So therefore x equals 1/3, and this is the second solution. We don't have to go back and check. We didn't square. We didn't cube. We can go back and check if we want to. Any questions? Okay, I promise for now the last type, absolute value. Please remember to redo all problems we did in class several times before you're able to reproduce the steps on your own. This is very important. And then choose some recommended problems, similar to the ones we did that have the answers in the back. So if we did 48, just do 47 and 49 and check the answer. Always bring all your questions to class so we can go over them in class, please. Okay, so here's a simple example, and then we pick problems from your book. So although this kind of looks linear, it's not linear. It's an absolute value equation that is totally different than the linear equation. So here's what this means. I'm asked to find numbers whose distance from 0, that's what the absolute value means. Distance from 0 is 2 units. What should I have in here? 5? No, because the absolute value of 5 is not 2. 0? No, because the absolute value of 0 is not 2. But what could I have?
-2 or.
Excellent. That's all I needed. Absolute value equations have 4 possible solutions. 4 possible answers. 1 is 1 solution. Number 2, 2 solutions. Number 3, no solutions. And number 4, infinitely many solutions. This we will not cover because I didn't see any, not even one problem in your book. So now I don't want to put more on your shoulders. This is an example with 2 solutions. I want to give an example with 1 solution. X plus 1 equals 0 in absolute value. The absolute value of x plus 1 equals 0. So what can I have here? What could x plus 1 be so that the absolute value is 0? X plus 1. Correct, x. But I was asking, what can this be? Exactly. X plus 1 equals 0, which means x equals -1. So this is an example for 1 solution. Let's look at an example with no solutions. Let's say x minus 3 equals -4. How come that I claim that this equation has no solutions? Why? Because this is a distance, and a distance is always a positive number, unless I have minus in front. That's a different story. But this is always a positive number. And can I find x that makes a positive number equal a negative number? This is always positive. Can I find x that makes a positive number be negative? No. So no solutions. So this is a type for this. And now let's look at a couple of problems from your book. You can choose anything you want from 61 through 76. 61 through 76 on 186. $67 it is. I would prefer doing even number problems just because I want you to do the odd problems, but that's fine by me.
68.
68. Doesn't matter to me. So 3 times 2x minus 1 in absolute value equals 21. So I want to write a note that is very important to note. The absolute value is not a grouping symbol. The absolute value is not a grouping symbol. What do I mean by that? It means that I cannot distribute 3 inside the absolute value. I cannot multiply or divide. I can't touch the absolute value as long as it has a variable in it. If it's the absolute value of 5, it's 5. But if as long as it has a variable in it, this becomes untouchable. I cannot do anything to it. There are 2 properties of the absolute value that we do not study in this class. So do not ever disregard the absolute value and say it's a grouping symbol or whatever. So you can't touch this. But I can still simplify this equation before I think about it. Absolutely. 2x minus 1 equals 7. That's all I needed. So now I can ask myself this question again. What can I have here? What can this number be? Or, that's it. That's all I need to write. So 2x minus 1 could be 7, or 2x minus 1 could be negative 7.
I just missed that.
Say it again.
I just missed that. How did you get rid of the 21?
Oh, I divided both sides by 3. It's multiplied.
Okay, so we got to get rid of the...
Yes. Anything else that is a weak link, yes, but nothing inside the absolute value.
Okay.
Yes, yes.
So let me just show that.
So then this one is 2x equals 8, or x equals 4. And this one is 2x equals negative 6, or x equals negative 3.
Why are we getting 7 and negative 7?
Okay. What can I have in here? What can this be? Right? So now the same question I'm asking for any other expression in absolute value. What could this quantity be? It can only be 7 or negative 7. It cannot be anything. No, that's okay. That's okay. Right? It cannot be anything else but 7 or negative 7. And that's how I get 4 and negative 3 respectively. Please choose another. Any questions on this? Of course, this was linear, so I moved 1 to the other side, becomes positive, and I divide by 2. And the same thing here, I move 1 and I divide by 2. Any questions? Okay, please choose another. And that will complete 1.6. Which one?
Did you say even?
Yes, I prefer even because I would like you to work on the odd and check the answer, but it's up to you.
72.
72 it is. Good. 72 on the same page. 4. 1 minus 3x, 3/4 x in absolute value. Plus 7 equals 10. Very good pick. Perfect. Not a trivial equation. You can't say that I picked it. Just kidding. Okay. So remember, you cannot touch this. Don't cross it out like that. I'm making a point. You can even look inside. You cannot adjust anything. You cannot do anything. But you can simplify the equation to the fullest possible. What will you do first?
Subtract.
And then you cannot subtract 4. It's multiplied. Yes, you can subtract 7 and you can divide by 4. 4 is multiplied. There is no symbol here. If there is no symbol, it's multiplication.
Okay.
Subtract 7.
So subtract 7 from both sides.
Yes, is that clear? So for the absolute value of 1 minus 3/4 x equals 3. And then the absolute value of 1 minus 3/4 x equals? Yes, indeed, 3/4. We divide both sides by 4. Any questions? So when I move 7, I got 3. When I divide both sides by 4, I get 3/4. Again, the same question. I don't have to memorize anything. What can I have in here? What could this be? Negative 3/4 or? That's it. That's how I get 2 possibilities. So one option is 1 minus 3/4 x equals 3/4. And the other option is 1 minus 3/4 x equals negative 3/4. These both are linear equations. And I know how to solve those. That's why we refreshed our memory on linear equations first. So looking at these two equations, I can, number one, eliminate fractions if I want to, or move one to the other side. You decide, whatever it is. If you want to get rid of fractions right away, let's multiply both sides by. Good? You want to do that?
Yes.
Okay, so let's multiply by 4, everything, each and every term. 1 times 4 minus 3/4, write it on the side, 3/4 times 4/1 and simplify. Minus 3x equals? Yes, equals 3. So I move 4 to the other side, negative 3x equals negative 1, and x equals 1/3.
So you didn't have to do
4 times 1 is 4.
Oh, okay.
4 times 3/4, 3. Let's go back and check. I always like to check. As we can, it's possible if we have a mistake. So same thing here. 4 minus 3x, but this time is negative 3. So then negative 3x equals negative 7, and x equals 7/3.